Welcome back to the shrine. Tonight we got a Ridgid Sawzall. Not even sure if this is called Sawzall because that's a brand name for someone else. A friend of mine handed this to me. He said it's got some issues, so you know, we're just going to perform a pagan ritual on the altar and gut it properly, go inside and figure out what's wrong with it. I can plug it in, then we can turn it on. So you can see that the motor is running, but the reciprocating end is not. Looks like it's moving some gears inside, but the motor is not driving it. It's got two different modes here, so I'm gonna go and try the other one. So nothing happens. This just blowing a lot of air into my face, but that's pretty much it. And every once in a while the business end will start to move, but I can hold it with my finger, so it's not much of a movement. So let's get inside and see what's going on. But first of all, let's unplug it. Looks like there is a lever here. So what this lever does, when you pop it open like that, you can move this foot in and out. So it's got a locking feature. So that's just a plastic lever arm, I guess. It's got two metal inserts here pressed into it, or insert molded into it. You can see these are metal. Yes, that's steel. Okay, this pin pops out, and now you can see how it works. So you can see that the pin, when it's turned in this direction, it's going to go into that groove and it's going to lock the feet so it doesn't move. And then when you turn it 180 degrees, it will allow a movement. So let's try to get this rubber piece off. Although I don't have high hopes, I can do that easily. There you go. Das boot came off relatively easy. And you can see we got a tear here when it goes over this switch. And I don't see any marking on it. It appears to be rubber, but more like some kind of plastic filled rubber. Oh, look at that. There's some markings. So it says EPDM. So EPDM is a rubber, is a type of rubber. It's got some color here. Fuego, something along those lines. Some kind of marketing stuff. Okay, so here's the unit. And there's some marking here. That's probably from the screwdriver when I was trying to pry this off initially. So that is just the holder for the foot, and then the pin provides an additional support. So let's get inside. Warm hearts and warm wishes. Perfect. To collect all the parts. Okay. Well, of course, that doesn't fit in. It's not long enough. You can slow me down, but you can never stop me. This is Torx 20. Fits like a glove. Well, let's go and look inside. Looks like it's a two-piece clamshell. And what we got here is an aluminum housing. And there's a lot of grease and debris in this area. That's not good foreshadowing. So you can see what happened. So this is the crown gear, aluminum, and then this is the bevel gear. Okay, so the bevel gear belongs to the motor. That's what drives this. And you can see that this crown gear completely chewed up and eaten by the bevel gear. So this is the section that does the reciprocating motion. You can see there's a little counterweight here. So when this whole thing is turning back and forth, you know, this mass here is moving in and out. This counterweight basically provides a force that's counteracting the inertia of this moving part. So that is supposed to prevent it from moving in your hand, acting like a jackhammer. Maybe we can turn it on, see what it does. There's a voice inside says don't do it. Okay, safety glasses. There you go. Broken gear in motion. So there you have it. That's the failure mode. I'm gonna go and try to take this section apart and see what we can do with it. Put on some gloves. There's just too much shmoo in this stuff. Maybe I unplug it first. So here's the selector. So this selector, you can see what it does. It's got a pin here that is going to set it in a specific position. And in the housing we have two spherical holes. And that's where the pin is going to sit. So that selector is moving this plate back and forth, and I think what it does, it's adjusting the angle of this piece here. So you can see it's got a slot, and that slot is not parallel with the axis. So maybe I need to remove that screw first. Ha! Look at that. So you can drive it from this side, basically. Okay. There you go. So the whole thing came apart. I was just trying to pull out the armature. So this is the armature of the motor. You can see it's a brushed motor. There's the commutator. I was trying to remove the armature, but it was not relenting. So you can see there are two screws here. So there's one here, and they are retaining this plate. They have to come out first, and then the armature is gonna come out. So now the armature comes out. This drive and bearing looks good to me. There's a metal plate here that retains everything. The fan is in good shape. The commutator looks good, and then this commutator and bearing also looks good. There's nothing wrong with the winding. So there's this washer. I'm not sure what it does. It was on the business end of this gear, but it wasn't attached, it was just loose. Okay, looks like the gear came out. So what do we have here? Oh my gosh, so much devilry. Okay, so this is not washer, that's a bearing. You can see that's a truss bearing. Here you can see there's a bearing, and then there's a bearing retainer, and then there are two screws, so they are holding the bearing that retains the crown gear. So that is that. Looks like there is some kind of metal plate here, press fit into the aluminum, that holds this steel piece. So I think this steel piece here that retains the shaft is moving, wobbling around here, and I think it just prevents the steel from eating the aluminum, so they put some kind of metal plate here. There you go. So this is just a pressed sheet metal piece that sits in the aluminum housing, and this is supposed to prevent the housing from wearing out during all that back and forth motion. That's a nice bearing, nonetheless. It's probably an expensive bearing. So here is the business end, and you can see it's got more devilry. So this whole thing is probably greased up in the factory. So what we got here is, you can see this retainer, this plate has these rollers, and the rollers can move in and out, and so when you turn the knob, that basically actuates it back and forth and changes the motion. So this pin comes out. So there's another roller here. These are all hardened and ground. So here's the pin. It's just a standard bearing pin. And that is the business end. So this is the shaft that is going to hold the saw, and you can twist it. You see it's got this twist lock, so when you twist it there's a release mechanism inside, and you can slide in the saw, and when this comes back it will retain that saw. And then this is the bushing that holds the whole thing together. So this seems to be a powder metal component, hardened, and it goes together like that. And then this rubber grommet, you can see it's completely kind of disintegrated. I initially thought that this gear is aluminum, but upon closer inspection you can see it's steel. The magnet is going to stick to it. This probably some kind of powder metal component. I still think this is a powder metal component. So at this point, this is pretty much end of story for this one, because you can see the gear teeth are gone, and this crown gear is attached to the counterweight here, and it's on the same shaft. You can see it's a D shaft, so they are keyed together and then pressed in the factory. And then this would be the connecting rod, and you can see that is also attached. So unless Ridgid sells this assembly, you know, this is beyond repair. So the teeth are completely gone. So this might be good for parts. If there's another one where the armature is gone, then you know, this could be used for parts. On the other side of the housing, it's basically the same story. So you can see this one has the same steel retainer, and then there's a needle bearing here. So this side has a large ball bearing, like I would say it's about a size of a, you know, roller skate bearing, and then this one only has a needle bearing, and that's due to the forces, how the forces are acting on it. So you got forces coming from the helical teeth of the gear, and so the forces are not going to be equal on both sides. Also, this needle bearing is going to take only radial force. It doesn't take axial force. So I can also imagine that, you know, the ball bearing here both takes the radial and the axial force. So that's why that screw is retaining the shaft to this ball bearing. So it's supposed to prevent axial movement. If there's too much axial movement, that's not good for this truss bearing. So here's the motor part. The strain relief looks to be okay. It's in good shape. The cable is in good shape. I would say this is about 8 foot. About 8 foot of cable. So let's go inside. That's also Ridgid. Okay, so this dude, this little pop-up cover, I figured out what it does. You can see this is the access port to the brushes. So if you just need to go and replace the brushes, then you can pop this off, and you can see there is a imprinting on it, you know, some kind of little icon, I guess. And there's a brush which is worn in. You can see the radius on the brush. That shows that the brush is worn in. And then it also has the spring here. So this is the primary mover, and you can see it's a brushed motor, all plastic housing. It's got a wound field stator. The copper wire seems to be in good shape. It's got some debris latched in here. It looks like pine needles. And you can see the wires here coming out. They attached to the brushes. So one here is a positive, one is a negative brush. I'm not sure which one is which. So we got one wire coming here from the switch, and here's the tag. Okay, the CIA tracker. So this tag is in almost every piece of machinery that you can buy at Home Depot. This is supposed to prevent thieves from stealing parts. And you can see this is not placed in a box. that you purchase it in, but it's actually placed inside the machine. So they deactivate this when you purchase the machine, hopefully, so that when you are crossing the gate out from the store, it's not gonna beep in, but that is the tag. If you want to trick someone, you just get one of these and put in their bags. Good luck. I didn't tell that to you. Okay, so there's the wire, goes to the switch. You can see that's the same wire, big beefy switch. And the way the switch is done here, the button, it is moving in this groove, so it makes it feel strong, I would say. So this is a three-legged device, and the part number on it is BTA 16 600B. And what it is, it's a triac. So when it's triggered, it will conduct. So it's similar to what we got in like a dimmer switches. So that's how the speed control works. When you press the button, you can feel that the motor is gonna turn on, and then the more you press the button, you know, the higher the speed is gonna be. So what we got here, this is a potentiometer. So when I press this, it's activating that potentiometer, and so that potentiometer is regulating the voltage basically on the triac, and the triac is providing a higher and higher voltage to the motor. So that's how the speed control works. And then this white wire here that you can see, there's a wire nut here connecting the white wire to the switch. That's basically thermal protection. So there's most likely a Clixton switch here, and what that Clixton switch does, when it's overheated, it will open the circuit, so we don't get more power to the motor. It will basically shut the motor off. So this switch seems to be in a good shape. It's a little dirty, but that's fine. There's no rubber boot on the switch here, so you can see how much dirt is accumulated on the switch, you know, from all the dust that this machine will throw up. You can see how big a fan there was in the motor. When I turn it on, this acts like a big fan, and it's just blowing air all over me. I'm just gonna put this back in. The motor part is basically working. It's in a good shape. I'm gonna go and look it up based on the part number, if they sell the crown gear assembly, and see what the price is. And I might try to fix this. At this point, I think if I can get a new gear set for 20 bucks, I think it's worth fixing it. Otherwise, this will just become one of those animals in the shrine that we sacrificed, and I'll put it in a corner, and it will be waiting for future command. Hope you guys enjoyed the teardown video and you learned something, and if you like the video, please give me a thumbs up, and if you like the channel, please don't forget to subscribe. See you next time. Bye.